Okay, let's continue on to use a conservation of energy lab. In this exercise, we're going to look at a pendulum and compare the velocity it has, or its energy it has at the very bottom of the curve, to the gravitational potential energy it has at the very end. So I've got a pendulum. It's very, very thin wire, just so that I get less air resistance. If I used that thicker yellow stuff we were using in our previous exercises, it would gather a lot more air resistance, friction, and stuff like that. Now there is still a little bit of friction. In this case, though, you don't hear anything. So it's quite silent. There's not a lot of, a very, very, very little. I mean, it may be some whooshing sound, but not that much. So what we want to do first is figure out what height I'm going to release it from. What I'm going to do is put photo gates underneath it like this to track its velocity right at the bottom of its trajectory. So if you set the initial gravitational potential energy equal to the final kinetic energy, you can easily solve for the speed that it must be going. Because of conservation of energy, you set initial mgh equal to 1/2 mv squared. And so we can calculate the v theoretically just by using the height, mg, the h. The m's cancel out, so we actually don't have to find the mass of the ball. mgh is equal to 1/2 mv squared. Then you solve for v, and you get your theoretical value of v. Then we're going to compare it with our experimental one. We're going to take a bunch of time measurements. So let's first figure out the height. So let me just move this meter stick a little closer. Meter stick. All right, so I know it's moving, but let me move it a little closer. Even closer. And I'm going to try and make it sit still. Stop. So instead of measuring from the bottom or the top, this is a brass ball. Its center of mass is in the middle of it, so we're going to measure from the middle of the ball. And you can see it's around 8 centimeters. So if we want, we can kind of, it's a little more than 8 centimeters. So you got to be careful about parallax error, actually. It's a little more than 8. It'd probably be easier if I move the photo gates away. Then we can much more easily figure it out, correct? So 8 is around there. Yeah, 8.4. So the initial height is 8.4 centimeters. Now I'm going to add 20 to that, and then I'm going to release the ball from 20 centimeters plus that height.